Hello everyone, this is Chris back again with the Ancient Scholar. I've actually been doing a little bit of pondering, and I wanted to do a supplemental video for all of you guys that are interested in some of the mathy aspects of respiratory therapy. And this kind of goes back to the video I did on the work of breathing calculus, and I kind of touched on this, but I really didn't go into any detail. I think this is actually critically important because we actually expose to this in general chemistry, and that is the pressure volume, the pressure volume relationship, or diagrams that we see in chemistry. And we know that we have a system. Generally, it's a system of gas molecules, and the system starts out at some sort of state. We'll just say this will be our initial state, our state sub I, initial state, and it has a certain pressure, and it has a certain volume of gas. And then what happens is, however, it doesn't really matter how I get there, but the system then goes into a different state. In this case, the pressure is decreased and the volume is increased. And then what I can do is I can then return that system back to its original state. And when we do this and we experiment, and you know, maybe I have. If you can see over here, maybe have a container with some sort of gas in there, and then maybe I have a little piston on top. I know my art's pretty horrible there, and then I have some little pebbles, tiny little pebbles on there, and I have some gas. I have some sort of pressure in here, and what I can do is I can take these little pebbles off, you know, ever so slowly, and of course what's going to happen is that pressure. The force, there's going to be a force exerted, and this piston is going to move up. Well, what is that doing? If I have a force over a distance, what is that defining? Well, force over distance is the definition of work. So in this case, going back to our pressure volume diagram, what we can say about this system is that the work that this system did is the area within this curve here. That's the work that the system performed. And obviously there are a whole lot of details about entropy and enthalpy and this and that, micro versus macro state variables and so on and so forth. Obviously pressure and volume being two important macro state variables. But the intuition that I wanted to convey is that the conventional way of looking at work in a system like this is actually the area within the curve of a pressure volume diagram. Well, this chemical concept actually applies directly to respiratory therapy, and that is we can actually monitor what's known as a pressure volume loop, and pressure can be a function of volume and vice versa. And I think this is an applicable way of applying work of breathing, because really that is probably the best indicator of work of breathing, and we actually use that graphic on our ventilators to determine, you know, what a work of breathing is. If there's increased work of breathing, do I need to add some PEEP? Do I have you know, perhaps over distension and things of that nature? So in fact, I think that the pressure volume relationship is probably a little more important, at least in my mind, than the time relationship that I talked about in the earlier video. Now again, to get this area, obviously the ventilators, the modern ventilators nowadays have microprocessors that can kind of do that for us in a lot of cases. The mathematics is still the same, in that I'm still using calculus, and I still need to do an integration, and of course, you know, I need to find you know, whatever the function is, and obviously I'm probably going to have different functions, and you know, you're looking at partial differential equations, but you know, so finding antiderivatives and integrating that is probably a little difficult, but still, that's, you know, how we would do it is through integration, and luckily of course we have microprocessors to do that. So kind of get back to the point, really what I want to do is to emphasize the importance of the pressure volume loop that we see on ventilators, and I really wanted to show you guys that that pressure volume loop comes directly from stuff that we've studied in general chemistry, or hopefully that we've studied a little bit in general chemistry, and we're trying, and now we're starting to make those connections. That's something that obviously thermodynamics and kinetics is not very intuitive, and it's very difficult to understand. But we're finding that these thermodynamic and kinetic concepts are being applicable, or a little more applicable to the respiratory therapy environment. So anyway, guys, I just wanted to kind of emphasize the utter importance of this, because I don't think I did in the other video that I did. So thanks for watching, and take care. Bye-bye.